What's up, guys? We're trying a slightly different format right here now. The challenge is going to be the primary device that was supposed to be used on this web stream is not really available. So we're going to do a little bit of back and forth. And actually, let me just trade something here. I'm going to go just normal selfie cam here. What's up? So, first of all, we're going to, hey, what's up, man? We're going to go ahead and the reason for this live stream. What's up, guys? How's it going? It's going to be a different dynamic today, actually, because I'm used to doing these podcast shows just typically recorded. So I'm going to have to get used to the audience interaction component of it, as well as the different camera that we're using on this. What's up, guys? Holy cow. Whole mess of people showing up. Appreciate that. But yeah, other than that, it's going to be a typical podcast. We're going to do the exact same format. So we're going to do news, some announcements, and then discussion topic. The discussion topic is pretty darn good for today. I'm reasonably pleased with what it's going to be. Thanks, guys. Appreciate it. What's up, everybody? Guatemala, Germany. Let's see here. Norway. Man, you Europeans, you guys are really into the 3D printing. And to be fair, the RepRap project started over there, so you guys get the right to that. But yeah, sweet. Let's see. I'm going to hang just a hair here. Let a few more people get on here as they're coming along. Yeah, talk amongst yourselves in the comments. If this works, if I am reasonably able to host this in a way that's semi-useful to people and semi-watchable, we'll try to do this a little bit more regularly. However, it will probably change what day it is because it is Sunday here where I am, and I don't know if anybody's flipped into the next day yet, but it's Sunday. And even though I do work 7 days a week, I am not a fan of having a required event on any given day. This is my fun time. This is the time to do other things. Let's see here. Yes, after I get done with news, I will try to take notes of questions as they're going by. And try to answer a few of those. Let's see here. Initial clients. Cool. All right. Well, we're going to head right into the news then. So, moving on with stuff. First of all, first bit of news today is the fact that we have a copycat popping up here of a few of our testing videos. Gentleman by the name of 3D Printer Academy, who you have actually probably all watched before. He makes really, really good videos about design of different items using 3D printing and optimizing for it, as well as more recently some testing videos. And he has been doing some beam testing, breaking videos of infill. And while I take a little bit of umbrage at the fact that he's copying our format and that style, I really can't take too much umbrage because we're all copying CNC Kitchen. So Stefan is the one who started it all, and I don't know why it was a new thing. I would say that in the context of those style of videos, ours are going to be a very different format because eventually we're going to get into very, very deep dives. When it all starts out with the Tangle Testing channel, which is open and live over on the other channel there, I recommend you go over there and subscribe, please. Thank you. The Tangle Testing channel is going to really focus on it's going to go into eventually really deep kind of analytical quality designs and testing. So we're going to try to get into the ASTM sort of standards and that kind of thing and get towards that. However, and a note on this to the general deep engineering part of the community that I know is very interested in this, we will be doing some more general tests because part of the issue with overall testing and the rest of it is that it's not very intuitive. ASTM tests are not useful to an engineer who's trying to intuit what a baseline kind of a rule could possibly be. So when we're working on the different tests that we'll do, some of them will be very generic and kind of like our very unscientific, I should say. Kind of like the Blender videos or like whacking something with a hammer or dropping it off a cliff, just to demonstrate, oh, that thing actually works in the real world. So let's go ahead and use that. So that will be something that will come up more regularly. So we will lean on that quite a bit. But anyhow, as far as 3D Printer Academy coming into testing videos as well, that's awesome. we need more people doing these types of tests here. So it's going to be, it's good to see other people feeling the need to add to the content and the information on that, because it's just so necessary for the community as a whole, that there's some testing into intuitive information and demonstrable information out there that everybody can kind of use. Let's see here. What do we got on questions? Tell me to swipe. I have no idea. We're trying the whole streaming format out here too. I'm running through comments right now. This is all going to be interesting. They actually required us to stream this vertical, and I don't know if that's because of the shorts format or something else. We might try horizontal later on, but let's see here. As an Etsy seller, what would you suggest to push product-wise to go after the 500 sales a year to 5,000? Should I blend in the crowd or stay in a niche? Here's the thing with Etsy. Etsy's super saturated. Everybody with a 3D printer is on Etsy. We have a lot of clients who use Etsy. And just like with any business, you have to be very differentiated. It's very important to find a product that you have that not very many other people have. Or some, I shouldn't say product, a competitive advantage. Do you have an audience? Do you know anything about digital marketing? Do you know SEO? Largely on the marketing side, or can you make a product that is good? But even if you have a product that is good, can you promote it and get it out there? What is our favorite 3D printer? My favorite 3D printer is the Slant Box V15, which has not yet been going into full production in our farm. It is the latest generation. It's finishing up development right now, and it will be the next few hundred to few thousand machines in both the Austin factory and the mega farm here. I know it goes against techniques you teach, but I need to create a 220 millimeter by 100 millimeter flat plate with large cutouts. So I'm looking for ideas to make the plate as strong as possible and reduce flexing. Use laser cutting or water jetting. Don't use 3D printing. That is my recommendation. Printing is a process, and printing should not be used simply because it's there. No manufacturing process should be used simply because it's there. So that probably was not the answer you were looking for, but it is the answer that is truthful and I'm going to commit to. Okay. What's up, San Diego? Augie's Hobbies. What's up? Let's see here. How do you manage product liability? Product liability is depends on the category of the type of product, because if you're making a keychain, there's effectively no product liability. However, every product has some amount of liability. You get product liability insurance and that kind of thing. There's all those types of deals. And then you also have to qualify and certify any product that you ever kind of make, depending on what industry it's within. Those standards might be set by the client. They might be set by a regulatory body. They might vary from country to country. Product liability is entire topicology that we don't have time for here, even on a live stream. What else we got? What's up, Gyrosoft? Let's see here. It's best in, just normal stuff here. Okay, cool. Moving on to news. This week, Desktop Metal filed for a mixed shelf offering for $250 million. This is effectively a way of raising funding very quickly. It's very similar to just an additional stock offering. So they've made more shares of stock of the company available. But with this mixed shelf offering, they don't have to sell all those shares right away. They are basically telling everyone in the SEC that, hey, we want to maybe sell some shares here. We're going to set these aside. These are going to be some things that we're going to put away. But they don't have to exercise them right away. This is a parachute that they're putting in place. Like, if we run out of money, we are going to want to very quickly get some money. So we want to have these shares of stock available so that we can sell them if we need to in order to get more capital. So that is a thing that will be, is an interesting kind of move. Desktop Metal, obviously, we've talked about them a lot, so much. They are in sort of a weird spot because they're still losing tons and tons of money. And since they lost the merger with Stratasys earlier this year, I'm sure that left them very much in a lurch to where they're in an unfavorable position that they weren't really anticipating or really wanting to have to engage with. So that's an interesting kind of wrinkle in the whole situation. But this wrinkle, these ripples of the nano dimension, Stratasys, desktop metal, the whole drama over this last year of the acquisition, merger, so on and so forth, is an entire. It's a whole thing that's still coming about and still engaging with everyone in an interesting way. So it's not a big deal because again, it's not a desperate act. It's actually a very calm, sort of prepared act of like, okay, we want to make sure that we have this if we need it, but it's also in a format to where we do not have to exercise it. We're not required to use this resource. So that's great. However, the other ripples in this is our next piece of news, in that Stratasys recently announced in their filings that there's been about 3 new firms that have taken 5% or more stakes in the company. Now, a 5% stake costs about about $47 million, because Stratasys is about $1 billion right now, about 920 or so. So 3 separate firms have taken a 5% stake. Ibrahimi also took a 12% stake, and we talked about that a week or two ago. So there are a number of external, fairly large investors taking fairly large chunks of Stratasys, which is also interesting because Stratasys is not really a growth stock. They're not the big movers and shakers. They're not the ones that are going to 10x in the next 2 years. They're barely keeping up 20%. They're taking the hits like everybody else. However, there's 2 theories on this. And again, normal comment, this is not investment advice. Some of us may have investments in the companies that we discuss, and this is for entertainment purposes only. Yada, yada. Cool. Disclaimer there. What this looks like is it's looking like either Stratasys is working with a number of different investors to protect themselves from effectively a hostile takeover from Nano Dimension, or there's an external factor that's working on a hostile takeover, which is using multiple different effectively shell companies to acquire large chunks of Stratasys to take it over. All of these companies have said that is not what they're doing, which is exactly what somebody in a hostile takeover would say. But no, it's very likely that Stratasys has just been getting a bunch of rich people together to kind of stabilize the company so they don't have to fend off acquisitions like Nano Dimension anymore, which is fair and good of them. Based on where most of these firms were based, they look like German or Dutch kind of firms based on the naming. I wasn't able to do a lot of research on them before the show, but they're interesting and they're large stakes to take because Stratasys generally doesn't move a whole heck of a lot of volume as far as share sales and that kind of thing. So yeah, there was that. That's pretty much for the news. There wasn't a lot that happened this week, guys, which is typical. So let's go back to comments here just real quick. Yes, we make our own printers. All of the print farms at Slant 3D use Slant 3D Slant box machines. There's nothing commercially available that works well inside of print farms. Certainly not at the scale that we do. So yeah, all of them are internally developed and internally manufactured. We don't use third-party machines. This has come up a lot, but the reason we don't use third-party machines is because printers today, regardless of manufacturer, are designed for consumer use. A machine that is designed for consumer use is completely useless in large-scale mass production where you're deploying hundreds or thousands of machines. It's fine for small print farms, that's fine. But for what we're doing, the very addition of like a data display on the machine adds cost, complexity, maintenance, and points of fault that we do not want inside the system. But all of the user friendliness and protections and that kind of stuff that are put into a consumer machine are fundamentally bad additions when building a production system. So they're not something that we really care about. Where do we buy 5 kg plus rolls of filament? We're making 4 kg spools. We're working on making 4 kg spools. We're delayed on that right now. But yeah, you can go to tangledfilament.com and get a pre-order in there for 4 kg. 5 kg gets so large that it's no longer cost-effective to ship, nor is it on a standard spool size that is easy and affordable to source. Right now, our filament extruder, yeah, that's actually an update that I have to do on here. The filament extruder dedicated to Tangled We have multiple ones, but we're keeping kind of lines drawn of the Tangled project and the rest of stuff. Tangled is that extruder has parts ordered. We have 10 spares of everything coming along, so it should be back up and running here in a couple of weeks. But we were delayed more substantially than thought because of Chinese New Year. Because we literally launched the 4kg spools at the beginning of Chinese New Year. The machine broke, and we have not been able to get the spare parts for it yet. We went through eBay and all the other resources and had everybody else in custom shops and that kind of thing quote making the part for us. It's just too expensive. It doesn't work. And Tangled as a break-even type of a project that is meant to just lower the cost as much as possible, there's not the margin there to substantiate airlifting some custom machine stuff in here. So we're getting that fixed, and it was a delay larger than we anticipated, but right now it's looking like about 2 weeks or so. So as far as materials, Naku, what's up? The choice of a material is dependent entirely on your application. There is not, oh, you should use this material for everything. No. You look at your application, you do an engineering analysis of it, and you say, okay, what material fits the specs that I need to hit? And you work backwards from that. You never start with material and say, make this product. You start with the product and then decide which material. And that is a kind of a first principles way of looking at, like, to solve this problem, what do we need to hit? And then once you have that spec, those data points, then you choose the tools and resources you're going to use, which is also true with, like, the decision to use printing or any or other sort of manufacturing process. Tangled filament available in Europe. So we would love to offer international shipping. There's a couple problems with this. The international shipping to many European countries is fantastically irritating from a customs standpoint. We never know if, for sure, absolutely certainly, that a package will make it through customs and be delivered to a European customer. Sometimes it's stuck in customs. Sometimes a European customer has to go to customs and pick it up. All these shenanigans. Sometimes it's just lost. And then there's extra fees and so on and so forth. So it's very often not a good product experience for a European customer. So then the question becomes, why don't you put a distribution or a factory inside of Europe? Wait a minute. We're coming to that. We're working on that. The plan is we should have a European print farm and therefore tangentially filament production in Europe in about the next 2 to 3 years. That is the expectation right now for Slant 3D. We have our Austin factory going up, and then we will do one more in the States fairly soon after that, and then there will be other ones in Europe outside of the United States after that. Is Slant 3D setting up filaments for engineering end use? No, we will not be doing that. Those type of specialty materials are something that somebody who is a full-time and dedicated filament manufacturer should be doing. And this is where filament manufacturers should be focusing. They should have a particular niche and kind of genre of material that they should be working on because they can get higher margins, more margins, more money, a more dedicated, easier to market to audience than the commodity materials. Like, the reason we started Tangled Filament was to completely commoditize PLA down so cheaply that almost everybody else would have to either go broke or make something more useful. So that's kind of been the goal with Tangled Filament, is to just force this price reduction all the way down to everybody. So it's not a big issue. Because the cost of raw materials is a radically huge issue for the scale of 3D printing. Like, what we do, we compete with injection molding. And when the raw materials are literally almost 10x the cost of injection molding materials, we have to be so much more efficient in so many other places that it makes our life harder than it should be, which is why we have our internal extrusion capabilities, so that our cost of raw materials is basically the same as molding. A little bit more still because there's just a scale factor there, but we have the ability to go as far as we can go. Let's see here. What's up, Alan Ortega? Apologize if I'm butchering that. I can't tell if it's Ortega or Ortega. Is it a long, hearty, or a softy there? Can you share any plans to make any more print farms in the U.S., and if so, what locations? We have our second factory going in Austin, Texas this year. Uh, Higher priorities than that are our software products and that kind of thing, which have gotten a little bit behind. So any spare resources are going towards those, but the Austin factory should be up this year. It is on the books. We've kind of planted the flag. We've had our office down there for a while, but now expanding out the manufacturing capability will be happening this year. That's one thing I back you on. Molding resin is bought by the ton, but the price to filament is just downright evil. The price of filament is not evil. I'm going to argue with you just a little bit on that and break the rule of comments of making you all happy. The price of filament actually makes sense in the context of how much distribution has to be done with it, because filament has to be purchased, and then it has to be marketed. It has to be sold through retail, who takes a third of it, and then it has to be shipped, because y'all have to have free shipping. This is just the nature of e-commerce. You cannot bill a person for shipping after they make the order, because it causes so much friction at checkout that you lose a substantial percentage of orders. So you have to move on to free shipping. You have to have free shipping if you're running an e-commerce operation. So with all of that in there, $25 a spool is actually quite reasonable to have a sustainable business. The only reason we're able to get down to, right now I think we're at 17, 18, and here in a couple more months we're going to be able to release $15 spools. The only reason we're able to do that is because it is partially subsidized by our primary 3D printing business, because we're basically scraping off the top of our raw material production in order to create material that is still reliable, but low cost, because we don't have to make as much money off of that. We're still making it profitably. I want there to be no mistake that we are going to make tangled filament profitably, because it has to be sustainable. If it's not, we'll burn out here in 6 months. So we have to make the moves that are intelligent to make sure it's sustainable. Otherwise, we'll just burn out, and then the whole point was lost. So yeah, filament manufacturers today do not overcharge for consumer filament. It's actually very difficult to do it profitably at the $15. And we have a few ancillary benefits, and we're just, quite frankly, Slant 3D is very, very good at manufacturing. Our team is very good at finding optimized processes, which is not universal in all manufacturers, even if they're a manufacturer. Apple Vision Pro. Oh, we should have put this on the show notes today. The Apple Vision Pro is awesome. From a technology standpoint, it is fantastic. And actually, we have here on podcast, we have a couple of conversations coming down where we're discussing the Apple Vision Pro. Actually, we want to do some accessories for it as a design for video, because, it's on trend. As a YouTuber, we got to find the stuff that is interesting and everybody else is talking about. But the Apple Vision Pro technologically is fantastically impressive. To be fair, in the context of the competitive market, VR headsets like the Quest are also quite impressive, but not as impressive as the Vision Pro, because the Vision Pro is wildly comfortable to use, and very, very Apple-ish. It's very intuitive and easy to work with. So yeah. Let's see here. On filament testing, can you cover warping and shrinkage? So the filament testing videos are focused on practical applications of the part after it's made. Very little of tangled testing, and I apologize for this, but this is a rule of the work that we're doing. Tangled testing is going to focus on the final result of the filament, either the part that is printed when it's printed correctly, or the raw filament material itself. We will not be testing individual steps in the printing process, like bed adhesion and that kind of stuff, simply because that is less useful to someone designing a product for 3D printing. Whether it warps or not is something to design for and be aware of, but it should be invisible to the end user. So they want to know, will this hook be strong enough once it's printed? Or is this material reliable for the part that I want to design for it? Bed warping and that kind of thing is a problem that's on the manufacturer to handle. So it generally won't be a very big testing feature. That being said, some components of like flow and print settings will definitely be tested on tangled testing. Let's see here. What else? Other comments have we got here? These are good. Keep them coming. These have been fun comments. Let's see here. Yes, our internal filaments will be tested internally as well, and we will put them straight up beside everybody else. And here's the thing, I'll tell you, for the low cost PLA, it will very likely be less strong and less durable than many competitors. Like Tangled is about lowering the cost while maintaining diametral and flow rate consistency. It is not about being the best quote unquote filament. It's about being the lowest cost raw material in order to make a shape. So cosplay, bulky parts, prototypes, that kind of thing. Shape analysis is mainly what Tangled filament is kind of intended for here, in order to get baseline capability out. And then over time, we'll introduce new capabilities. Right now with Tangled, we're talking with a few manufacturing partners who are on board with the mission, who might be able to do some more engineered or variable grade type of products. In areas like TPU and PETG, those will be coming down. Let's see here. What else have we got? Will there be technical data sheets for the filaments? There will be data for the filaments. A full data sheet likely not at start. There's a need for a website for the Tangle testing data that we're creating, and that website would effectively end up with basically tabs or pages for each material from each manufacturer, and we just add data to it as we get new data and do additional tests. But the full data sheet, quite frankly, is not our responsibility. Manufacturers should be providing the full data sheet, but they're not right now, which is the reason for Tangle testing, which is to put pressure on them and also kind of call BS on anything that they are doing. Okay. PLA Plus is, it would be nice to have some testing on PLA Plus, as some are very durable while others are not too different to standard PLA. Alan Ortega. Thank you for that comment. We've talked about this in a previous video. We have a video, I think, called PLA Plus is a sham. PLA Plus is a sham. It is either a brand name or a differentiation of material, and it varies depending on who is making PLA Plus, which is a primary issue. You have no idea what the material is. There is no material spec. There's no spec sheet. So you cannot compare one PLA Plus to another, because PLA Plus might over there be, oh, we make it good, and PLA Plus over there might be a wholly new material. So it's a different kind of a monster. Okay, let's see here. What else we got? Okay, that'll be good. All right, I'm gonna move on to the next thing. We just did a solid 10 minutes on comments or so. I'm gonna do a random swipe and see if we find anything good. A little higher, a little more, a few more. Here we go. Those are just okay. Send a football to Pat McAfee so he can kick it. That's actually a good idea. The football video, we're doing a follow-up video to the football video because we did not have enough demos in the edit, because quite frankly, we were just up against it on the editing timeline for the football video. But we will be doing a follow-up video where we effectively do the full test of it all and that kind of thing. So the football video will have some follow-ups because the football is really flippin' sweet in how good it is as far as the thing, because it does solve so many problems. It's so much better than the Wilson ball. The Wilson ball is dumb. And, well, I guess this live stream is recorded, but the Wilson ball is still dumb. So, yes, we're getting that all fixed. But yes, the football will be going through kicking tests, compression tests, that kind of thing. We'll put it in the compression rig to show them how much pressure it has compared to a regular football, all the things. It'll be a lot of fun. Let's see here. All right, moving on to topic of the day. Investors and investment in a private company. This came up this week and was also just on the list of topics, so I thought I'd cover it because it's useful to people. I had a conversation with a guy who was starting up a company, and he was asking about investment. And for context, personally, I have operated in the tech industry for quite a while. I have been involved with funding rounds historically. But for Slant 3D is a fully bootstrapped company. And that means that we have not taken an external investment. It's like you make money and you spend the money that you make. That's what bootstrapping means. But for a company in the 3D printing space to raise investment right now is exceptionally difficult because manufacturing is unsexy. Physical products are unsexy. And 3D printing has lost 90% of its value in the last 3 years, so it's unsexy. And also, most of them have proven out to not have the venture capital type of growth rate that is necessary for venture capital. This is what many people do not understand. Venture capital is a very, very weird sort of business model that many people struggle with, including, by the way, investors. Investors are very bad at understanding venture capital. Venture capital is a wildly skewed return ratio. You will have 9 or 10 companies, and 9 of them are going to either go to zero or exist and maybe grow at 5% a year, which does not work. For the venture capital market to value to work, business model to work, you have to have not a 10x return, like a 100x return on a single investment. You put in $1 million and you got 1 billion back. That's the only way venture capital really works. Here's the thing. Venture capital, good venture capitalists understand the timeline over which that growth will occur. There is a misconception, again, within investors and normal investees, that they have to 10x in 1 year. And that occurs sometimes, but that is exceptionally rare and is less reliable. Amazon is as big as it is because Amazon relies on compounding growth of 20% every year for the last almost 30 years. They had a huge burst at the beginning. They went from $0 to $1 billion in like 4 years. Yes, great, good to them. But since then, Amazon has maintained a 20% growth rate. And that is what makes them so valuable. They did the small things right. And every venture capitalist over there has made off like a bandit. But for you as a person pursuing investment, you have to, again, we had a conversation about this a couple weeks ago about being honest with yourself. You have to be honest with whether your company can maintain that type of investment. And to be fair, you shouldn't necessarily evaluate this yourself. It is kind of a conversation to be had with investors or someone else who is an investor who's a third party who can look at your company and say, maybe, or yes, you probably should. You have the justification to get there. If you are pursuing investment, you have to understand that you are taking on capital that is both very expensive and has exceptionally high expectations. Investors do need a return from their money within 10 years. Very often they don't get it, and they know that, and they understand that, but they're still going to be pushing on you the whole time to get it. The other thing is that the investors, you have to be picky about your investors. This is what a lot of entrepreneurs misunderstand. They think investors are just money bags, and they're like, oh, all money is the same. If I can get the money from somewhere, it's great. And that is a very definite mistake. I'll give you an example. Last year, 2 years ago, I actually don't remember now, Slant 3D was we were making an attempt at a venture funding round. And we spoke to a number of firms both here and down in the Valley. Boise doesn't have an actual present or real or substantial investment community. So we had to go elsewhere. But we eventually received a term sheet. And that term sheet pretty much met everything that we were asking for. Because quite frankly, at that point, we were sort of undervaluing ourselves because the money was more important in order to do some of the stuff that we wanted to do than not having it. So it was like we were willing to take a hit on valuation, and they actually, this is really weird, but the investors came back with an offer that was better than what we were asking for. One red flag on it. The term sheet that they sent to us had a no shop clause. And this should be a red flag to anybody who's an entrepreneur who's starting a company. A no shop clause means that you cannot talk to other investors. Now, there's a certain amount of justification in it because investors do not want to give you a great offer and then have you go send it off to another firm and they make a great offer. I understand that from their business model as far as protectionism, but it's also stupid because if they give you a no shop clause, they have put their needs ahead of yours as the company. Because all investors always market themselves as like, we're so good to entrepreneurs and we're so good to companies. You should come work with us because we'll help you. But if they start off with a no shop clause, they are immediately invalidating that because they are not operating in your best interest. If they are truly the best option, they shouldn't care. And a no shop clause is also dangerous because once you sign that term sheet, the term sheet is not binding. They do not have to give you the money. But that no shop clause is binding to where if you shop it around, they can sue you for whatever their time and money was in it. They probably wouldn't, but anyhow. So be aware of the politics in that. Anyway, we did sign the term sheet because we liked these guys. We were working with them and that kind of stuff. And we went through the entire process and it didn't close because it was it was beginning of 2023, 2022, 2023, when the startup tech market, effectively the bubble burst. And then you had Silicon Valley Bank and so on and so forth, all the things that to where venture funding for startups disappeared because there was no secondary market for startups. And a lot of these seed fund investment firms would invest in a startup and then they sell it off in a Series A effectively, and that's where they make their money. So there's a bad investor experience. I consider it to be a wildly good success because there were a number of issues to where I think we dodged a bullet in working with that firm to where they would have hampered us in a number of ways down the road. Side note, we're always open to investors. But Slant 3D is a company that has been, I think, operated well enough and is in a good enough business model that, quite frankly, is very investable, but is on a trajectory to where we don't necessarily need investment. And venture capital is slightly overrated. It is useful. It is useful, but you have to know that you're using it. Venture capital is almost more expensive than credit cards, literally, as far as interest rate effectively. Because if somebody invests with you for $1 and then you 10x, they get $10 back out of you, which means that they just got 1,000% interest off of you. That's what you gave up. That is venture capital. But now the alternative is that banks will not give startups loans, and good venture capitalists are able to open up doors for you effectively like a partner that can be really useful. Because like if you get a venture funding from freaking, let's say Sequoia or Andreessen Horowitz or something like that, they are going to introduce you to some people who are going to become customers. So it's, yes, there's all that. In order to raise venture funding, number one, make sure that you need it. There's no other options because venture funding is stupid expensive. Make sure you understand it. Make sure you are picky. Go through the 50 different investors, and while they're asking you questions, be interviewing them as well because they're a part of the company. And this is why so many entrepreneurs get screwed. They get dollar signs in their eyeballs rather than looking at the people writing the check because those people are just as important as the dollars themselves. Because a company is a group of people. If your people are screwed up anywhere in the process, it jacks up the entire company and you end up fixing the mess down the road. And there's an endless number of messes to deal with, so there's no reason to harp on that any more than you have to. Okay, let's see here. Okay, let's go back to comments here for a bit. That's it. That's investment funding. I could probably gracefully move out of there more, but I'm just gonna go to the comments because there's a bunch of them going by. Let's see here. What else we got? It's taking me a moment to go through these. Searching for remote 3D design jobs. I consider myself a very good designer. I do have a 3D printer. Appreciate that. We are not hiring for 3D designers right now. Here is a note on this as far as applying for jobs. If you're applying for a job at a company, make sure you send a link to your portfolio, include your resume, and say why you're good for the job. And why you're good at the job, quite frankly, is not that you have a 3D printer. What is the awesome thing that you've done with the printer? You have to demonstrate having used it. Having a thing is like having a degree. I have zero interest in what your degree is. If you have a degree, I want to know what you did with it. What was the awesome thing that you did from the knowledge that you gained from that degree? So when applying for a job, be aware of that. Let's see here. How often do we go live? Never. This is the first time we've ever done a live. We might do it more though. This is going fairly reasonable. What CAD programs do you recommend for a hobby enthusiast use? I can tell you guys use F360 from the videos, but I have been using Onshape. A CAD program is fully discretionary. I cannot make a recommendation right now. I don't pick the one that works for you. It's kind of like, do you use a ballpoint pen or a fountain point or whatever else it was? It is, that's pretty much the way that goes. Let's see here. What else we got? Okay. Could you please do more content on the actual pricing behind your kind of service? How much would 10 of these egg TPU PLA enclosures be printed by you? So our pricing system uses about 20 different variables when it's run through, and then it has a final person kind of evaluate it to verify that the computer's not going insane. Because analysis of 3D models is phenomenally finicky because computers would be stupid. But the excuse me, the pricing system takes into account, of course, material, print time, all the common things that everybody thinks of. But then it does an evaluation of print complexity. In our case, how automatable is it? Post-processing steps, all of those things are in there. And effectively, what we do is we take into account all of the core costs that we would have at that volume. And then apply a certain amount of margin onto it, depending on the context of the part and the competitive landscape. So there's 20 different things, 20 different factors to be evaluated on any given quote. Because an ASA box is totally different from a TPU scrunchie. It's like they're just different monsters. So based on the quality that the client is pursuing, all of those kind of things, those are all terribly important things. Have you considered franchising your business model? This has come up a lot. And actually, we get reached out to by other print farms quite often of like, hey, I've got a print farm over here. Can I plug into the Slant 3D system? And the benefit to it is that somebody else buys machinery. Someone else, we get faster distribution because you have a printer over in Australia and a printer in Germany tomorrow. But the model doesn't work because a factory is way harder, quality is way harder, consistency is way harder. Since printing does not make the same ice cream cone over and over again like a McDonald's does, franchising doesn't work because a printing service, a custom product service, does not work in a franchise model because there's too much internal expertise that's necessary that is not transferable or trainable. It can be learned over years, but there's institutional knowledge that just can't go to a franchisee. So no, we will never be franchising any part of the Slant 3D model. We will build all of our own factories for forever. We'll end up growing slower, but it will be a better service and a better client and customer experience because they know what they're getting from a Slant 3D provider. The franchise model has been tested by 3D hubs. And it broke them and it failed. So one of the easiest things that you can do are learn from exact correlative errors from the past and just say, I'm not going to do that. If I'm going over that road, I'm not going to hit that pothole. Now, there are situations change, technology changes, and the world changes. So something that didn't work in the past may now work now. There's such a thing as being too early and all the rest of that. So you always evaluate those questions when they come up and you circle back around on them once in a while. So it's like for us, should we be doing resin rather than FDM? That's a question that we ask almost annually, if not more often, as each new person joins and asks the question. But that's the technology hasn't reached that point yet. Okay, let's see here. Blender is great for organic shapes, tougher for engineering parts. Let's see here. What is the best infill for strong 3D parts? Gyroid, cubic, and grid, I think. It depends on the part. Each infill has its own capabilities. There's a few of them that are absolute garbage, should never be used. Like lines. Lines has no structure to it, but it has really good wall support. So actually, it's one of the weaker ones, but it's actually really good for surface quality. When will Tangled come to other countries? I covered this earlier in the stream just because you're late. But no, the Tangled filament will eventually very likely come to other countries. But right now we are focusing, you have to keep your eye on the ball. And we cannot spread ourselves too thin with having to deal with international customs and distribution or external other country manufacturing right now. So Tangled is going to be restricted to the United States. We're working to get it expanded to North America, you Canadians. We're getting there, but again, shenanigans, and it also hurts the quality of the product because if you're paying so much for shipping to get it there, then there's no value in it to you. And it's also no value to us to do all the work to prep for that version of production. What slicer software do you use? Depends on the product. Each slicer software has its own capabilities. We of course use every slicer software that's out there, and we have some internal tools that we also use. So there is no magic slicer there. The Innovator's Dilemma. Taz Bridges, thank you very much. Yes, The Innovator's Dilemma is a book everybody should read. 3D printing is very much in that situation right now, especially FDM. In The Innovator's Dilemma, the story he uses, or the example he uses, is the steel industry. All steel used to be made from raw ore dug out of the ground and then smelted into the freaking I-beam or whatever it happened to be. And that was a higher quality product that they were able to produce. But then these small little smelting plants started popping up that could use recycled steel, so like rebar and other garbage. And they started making rebar, which was a garbage material. Nobody cares about rebar. It has a very low standard of quality for it. It's like roughly round and won't rust inside of concrete or something like that. But those smelting plants started with rebar because it was low, cheap, and easy, and the big expensive plants let them have it. But then those small smelters got better and better and better over time until they just finally ate the big guys from behind. And printing is very much in that same situation, especially FDM, because FDM has a very clear roadmap for improvement, and things like high speed have already proven this, to where it can come up from behind on injection molding, and it has all these other ancillary benefits of efficiency and that kind of thing. Stupid but fun question. How many benches could you produce in 1 hour? Benches could you produce in 1 hour? I could be all waffly and be like, well, it depends on the material and the print speed and how many machines we want to do for it all and that kind of stuff. If you had used an example other than a benchy, I would have responded to that. But I hate the benchy model. The benchy model is ridiculous. And I have never printed a benchy in my life. Not to be antagonistic, but the benchy is a terrible model. Will you go into compliant mechanisms with other filament types other than TPU? You can do a compliant mechanism with any material. Live hinges are technically a compliant mechanism. The way to build a compliant mechanism is just to make sure that you stay within the plastic region of stress strain for any given material. So any material is flexible to some degree, so you can make a compliant mechanism. Like, yeah, a steel tube straight up in the air has an amount of flex to it to where you can make a compliant resonator or spring or something there. So it's all doing there. When are you doing a factory tour? We have a number of factory tours on the channel. We show the factory quite often as B-roll inside of the videos. Full factory tours are very difficult because we always have client projects on there, which frankly are proprietary, and we protect the work that people give to us so that we don't share that around. A, so we don't get sued, and B, so that we're just not idiots and protect the stuff that people give to us. Because when somebody designs a product, they certainly don't want it to show up on Instagram of like, look at this awesome thing. So the 3D printed tours are tough because we would effectively have to shut down the whole factory to not show something that is sensitive, either especially from clients' perspectives, but also internal development projects, like the version 15 version of the machine and that kind of thing, which is in testing, or other goodies that may or may not be there, that kind of stuff. So factory tours are hard. What's your take on printed threads? I favor them for connecting chunky multi-part parts because they are low effort. 3D printed threads are fine. I would say that they're more effort than a few other options. For joining multi-part parts, there's a few other ways of kind of doing a snap fit that I would say are almost easier to model than threads and certainly more printable. Because threads are very hairy. But yeah, for chunky parts, they're fantastic. So yeah, I would use them all over the place if you're able to have them seat in the correct position for whatever parts you're putting together. I think they're fine. Printed threads have the problem of having a stress concentration in them because most people print threads vertically, which means the layer lines are going through them, which is not the greatest because you put all those threads into the hole, but literally it's just the upper layer adhesion point that actually creates any strength. So they're not the greatest. Have you played with the material from BASF that allows for you to print 316L stainless steel? No. We don't do steel. We don't do metal. We don't do the metal-filled materials. Metal-filled, metal prints and that kind of stuff are all in a really weird spot because FDM with metal requires post-sintering. And this is what has screwed every metal 3D printing company that's not using EDM, is that it shrinks so much between printing and sintering that you don't really know what parts you're gonna get out. And the dynamics of it are so weird as it shrinks that you don't really know what you're going to get out. And I'm pretty sure this is what has kind of screwed Desktop Metal with a lot of their metal offerings. I don't know that for sure, and those guys are really smart over there. But Desktop Metal was this close to effectively being a fraud or a Theranos story, to where they're like, oh, we're gonna get metal 3D printing, and they almost didn't get metal 3D printing. So again, I said this wasn't investment advice and everything on here, right? Yeah. But it's something to be aware of because metal printing is fantastically difficult because the thermal expansion coefficient of these materials is bananas, to where it's very difficult to maintain stability, whereas thermoplastics have very little shrinkage compared to metals. Yeah. I want to start a 3D printing shop. How do I start? I have 2 printers. How to price my prints. This is interesting. Almost everybody prices their prints incorrectly. Everybody looks at, okay, I've got this much material in the part. I'm going to add another $1 on there or something like that. That is the complete and total wrong way to price. The minimum price that a product should be is the cost of manufacturing times 3. It's called the rule of 3. It's applied in retail all the time. Whatever price you see on the shelf, the cost to make that was 1/3 of it, because you have 1/3 of the cost to the manufacturer, 1/3 of the cost to the distributor, and 1/3 of the cost to the retailer. And that is the minimum that you have to hit in order to have a viable business model in retail. And if you are selling on e-commerce, you should still be following the same model because people shop in the store and online at the same time. So the rules still apply. So whatever it costs for you to make, you have to add on your margin and then multiply that by 3. And then you have the correct price because now you can do retail. Now you have scale. Now you can buy marketing and ads. All of that stuff is a part of it. So yeah, whatever the cost of it is to you to make, which includes the material and your time, which people do not understand. And your time is whatever the hourly wage is, and generally, very often, many people use the minimum wage. But this is a phenomenal misconception when people say, I have 2 cents of 3D printing material inside this little widget or keychain. I'm like, no. Did you spend 2 minutes starting that print or removing that part? Did you spend 5 minutes post-processing or removing supports? Did you then spend another 5 minutes printing the label and then putting it in a box, which, by the way, the box also has cost? Okay, you just spent 10 to 15 minutes preparing this order. at, let's say you paid 20 bucks an hour, slight above minimum wage of like 15 bucks an hour, because 15 bucks is the minimum wage in the States. 20 bucks an hour, you spent $5 plus the cost of the material on there. And then if you really want to get into the analysis, you can talk about how much your actual print machine time is and that kind of thing. But yes, the cost of your thing is your time to make it plus a margin times 3. That is the minimum pricing that you should use. Okay, let's see here. How much would you need to make and how much can you produce? Come up with a number. Yeah. I'm sorry, Joaquin. Don't do that. Do the rule of threes. Whatever it costs to make you time 3. That's the minimum. That's the minimum you have to price a product at in order to be sustainable. Otherwise, you'll burn out. Always. You can't afford the ads. You can't afford the shipping. Something along those lines. Worth hiring your farm for and scaling your prints. Thank you so much, Zabeardo. Look forward to the day I have a project worth hiring your farm for my scaling prints. That's exciting because that's the main reason we built the farm. The reason we built the farm is we had a product that needed to be produced and there was no one else available to do it. So that's the reason Slant 3D was created originally. But now to be able to enable people to use it and quite frankly, enable people more because we're trying to get away from kind of the traditional job shop model into a more automated like service software upload model, which hopefully will make the cost effectively 0 to get started. Because right now, if you contract Slant 3D, there's setup fees and that kind of thing. Because just to take a call, there's a person who has to take the call, which is an expense. So the cost of using us right now is higher than I would like it to be. So we're trying to make it more efficient by just using more software tools to make it really easy. Will you ever do collabs with content creators on YouTube? Stand by on that. We have a few announcements coming down. And I'll leave that there. What are your thoughts on nozzle size and diameters you've mentioned in previous videos? You guys use 0.4. Is that your preference for a specific reason? Yes. First of all, 0.04 is the most common, which means that if a client has printed a prototype, 0.04 is the most likely to match it. 0.04 also has the smallest diameter with still reliable flow rate. Whereas if you go to a larger nozzle diameter, you end up changing the architecture of the machines. But a big part of the decision mainly is compatibility. And that might change in the future if we're really trying to go for specific SKUs or product niches. We might introduce larger diameters at some point. And if we're trying to improve quality more, our thoughts on quality or print speed and that kind of stuff is that print speed is the cheapest commodity that we have. So if it improves the quality of the product, we would slow down the printer because we get the scale from the number of printers that we deploy. So nozzle diameter very possibly will decrease into the future a little bit because it's sort of like a supply and demand curve. There's a sweet spot where the two intersect where you don't want to go smaller with nozzle diameter because it slows down speed and so on and so forth. So 0.4 right now is good. Product should be able to cover itself. A defect or other lines defects too. I'm not sure what that was. As someone new to 3D printing and looking at using it to help make models for Silicon Medical task trainers, I thank you for all the information you put out. It's been super helpful. You're welcome. Thank you. Life holds strategic. Appreciate that. Can you make a printer on video on 3D printer maintenance? No. The rule for the Slant 3D channel is that the content has to be useful to a client. Despite popular belief, we are not a 3D printing channel. We talk about how to make final products and how to design good quality final products, but we do not talk about the print process itself because that's our job. A client shouldn't have to worry about how the sausage gets made. They should say, I want a sausage, and the sausage shows up. So on the YouTube video, we don't talk about individual processes of maintenance or what machines used or slicing parameters or any of the rest of that stuff. It's just not useful to someone trying to make a product. And there's a lot of other people who do it and quite frankly do it better than we would. Our core competency is how to get scale and how to make final products. That's what we know. Identify a product idea, you can charge what you want. Well, that's true. you certainly want to have a product that is differentiated enough and valuable enough that you can effectively charge whatever you want. And those generally are problems solved in very specific niches. A lot of people do really well in the gun industry. A lot of people do really well in particular parts of gaming. Those are all niches that work really well. But quite frankly, being successful with a product is having a much more holistic understanding of business marketing and product creation than many people realize. Many people think you create the product and then the product sells and flies off the shelves. Build a better mousetrap, the world will beat itself to your door. Unfortunately, that is not the case. It's very rarely the case. Super rarely the case. The world does not beat a path to your door. You are going to beat the path to every single one of their doors. And you have to find a way of doing that in an affordable fashion. And then you have a product that's successful and everybody thinks you're a genius at some point 10 years from now. What's the hardest durometer CPU you currently work with? Also, how high could it go if manufacturers made it harder? Right now, about 85 to 90D is the highest TPU we've run into. Most manufacturers don't make it harder than that because they're like, there's ABS right there. What are you talking about? We like the higher durometers because the TPU is a better material than all the other materials, except for the fact that it sucks water out of the air, which is unhelpful, especially as we start doing coastal print farms. But how high could it go if they wanted to make it harder? You can theoretically make it fully solid. And quite frankly, 95D I think is like, or 90D, 85D is about as hard as like a hard hat. So it's not really, there's nothing much harder than that to a reasonable person looking at it. And you could be like, oh, sure, hardness is harder, but yeah, it's like nobody notices or knows. ABS, each plastic is effectively indistinguishable once it gets to 85D. What layer thicknesses do you use? Whatever the client requires. Layer thickness is defined by the application. Let's see here. I have 20 years as a, oh, wait. What can I do to bring in more customers? There's no magic bullet. There's no magic bullet. I wish I was one of those gurus who was like, you guys got to go out there, you got to start using those Facebook ads or whatever else it was. I'd love to, I wish that was a thing, but it's not. There is not a magic bullet for getting more customers. To get more customers, you have to talk to more people. And the way of talking to more people is to buy more ads, get more followers, or do whatever it happens to be. I wish there was a better way of putting that, but learning marketing and sales is the only way to get more customers. And those are so multifaceted. There's not a bullet that does it. Doing character bus, what's your best advice on starting out? 3D printing has an allure of that you can make anything. But then the question becomes what you can make. If you're making character busts, it's super dangerous because number one, there's a lot of people who make character busts right now, which means you're in a really competitive space. And I'm sorry to be I feel like I'm being really negative on this thing, but the competition is really brutal in that space. So you have to differentiate yourself in some kind of a way. So I don't know if it's color or bigger or different or what you're doing there. This is Peter. But for character busts, why should somebody buy them rather than someplace else? Answer that question. Why should they buy them from you rather than from someplace else? That's the first question that you should answer if you're starting out there. And then once you have the answer, that becomes your marketing. How quickly do you think you will adopt crazier FDM techniques such as multi-axis 3D printing? We're not going to. FDM is fine today, and it has been so far from optimized. There's so much to be done in optimizing it for the print farm. I was actually talking with the dev team about this the other day. Our printers are overcomplicated right now. We have to continue to push them back, and I want to delete so many more parts, and they can be so much stupider at the machine level because there's so many ways to get around it. Should do these live Q&A news sessions more in the future. Thank you, Stanley. Appreciate that. We'll try. But they're going to be on a different day if we do them live because I can't do this on Sunday all the time. Just can't. Let's see here. What else have we got? Any chance of opening a facility in Texas? Austin, Texas is going in this year. What's up? Okay. How to go about building a farm with non-desktop printer. A farm is by definition a large number of machines. A desktop printer, if you're buying a consumer device, I highly do not recommend it. We use our custom machines internally, which are optimized for print farms. They are desktop size, but they're not desktop machines in the traditional sort of sense. They're just small build volume, which quite frankly, Stratasys machines have a small identical build volume. They just have this giant monster bunch of infrastructure around it. Yeah, there's all that. Let's see. Okay. Well, guys, we have crossed into the hour, which is as long as these podcasts ever generally go. So I'm going to start wrapping it up right about there. Thank you all so much for watching. This was fun. This was interesting. We'll probably try this a couple more times because we're messing with formats on the podcast to see what people like and don't like. So do let me know if you like the format and what we're trying to do with this. We have a few different recording formats that we're doing for the podcast, which will be coming out next week. I think you'll enjoy it. We're pursuing kind of the interview, and the guests are really good, and it's been a lot of fun. But thank you all so much for watching, and I'll let you all get back to your day there. And yeah, we'll probably do this again because this went pretty darn well. So I'll let you all go. Have a great day, everybody. Let's see how we're going to find out how we do this.